Welcome back to the channel. Today I'm gonna show you 4 different tools I wish I knew when I started aerospace engineering. So engineering is all about practical stuff. At the end of the day, you have to create something new or fix some problems at least. But the majority of time, what happens is that 90% of the time you spend at the university is about theory, and only a small fraction, 10%, is about practical stuff. But when you go out in the real world, it's the opposite. So it's 90% solving problems, creating new stuff, and 10% theory. So if you will learn these 4 tools that I'm gonna show you today, by the end you finish the university, you are gonna be ahead of 99% of your colleagues. And at the end of the video, I'm gonna give you a bonus one, a tool that everyone can use, even if you end up working as a freelance engineer like me. Okay, let's go. So the first tool that you must know how to use it is called CAD, Computer Aided Design. So basically, these are the kind of software that helps you draw something in 2 or 3D that you can use in real application. There are a lot of different software when it comes to CAD design, but the one I like the most is called SolidWorks. Probably some of you watching this video are gonna complain about this software because it's really expensive. I've got a solution for you. First, if you're still at the university, you can get this one for free or some kind of similar software, because the university have some type of licenses for students, so you can access this for free. Now let me show you how to use SolidWorks.
First thing to do is go to this website called Airfoil Tools and pick your own 2D wing. For example, let's pick this supercritical airfoil. Click on this and you will have access to the coordinates. Copy those into an Excel spreadsheet and remember to add a third column with all zeros, which is going to be the Z coordinates. Save it and import those coordinates into SolidWorks. Now you have your 2D wing profile, and using some built-in function of SolidWorks, you can create other planes and copy the 2D wing profile like this. Select the distance of your wing, and now you can combine the 2 profiles to have a real 3D wing. And now you're ready to move to phase number 2.
So now that you've seen the power of this particular software, we can move to number 2, which is all about, guess what? Simulation. If you're an engineer and you want to draw something, why you want to create something in 3D if you're not gonna use any simulation on this piece of drawing that you've just created? So there are multiple types of simulation that you can do as an engineer. You can do mechanical, you can do aerodynamics. For this specific video, I'm gonna talk about aerodynamics, which is my area of expertise. So we're gonna talk about CFD simulation, computational fluid dynamics. And when it comes to CFD, the best I can give you is ANSYS. So ANSYS is a software that allows you to do any kind of simulation. As I said before, from mechanical stuff, stress analysis, and in this tutorial I'm gonna show you aerodynamic simulations. And when it comes to CFD, ANSYS has a special package called Fluent. And this is the thing we're gonna use.
First step is to open Space Claim and create the fluid volume around your wing. So select the distances and you can create surfaces like inlets, outlets, the far field. Now we have to create the mesh, which is usually the most time consuming phase of any CFD project. I'm not going to go through each data that I'm inserting right now, but this is a typical mesh of a 3D wing. After that is going into Fluent itself, and you can see the mesh around the surface of the wing. In Fluent, you have to select everything about the simulations. So from boundary condition, turbulence model, everything. The temperature, from the velocity of the flow, everything. And when you're comfortable with that, you can select the number of iteration of your simulation and check for the CL, CD, the residuals, and after that, your simulation should converge, and after that, it's time to pass to the next phase.
Okay, step number 1, draw the thing that you want to simulate. Step number 2, do the simulation. Okay, but what happened now? We got to step number 3, which is validation of the results. So to validate any kind of simulation, you've got to see some kind of results. So if we follow this path, we're gonna use now the post-processing tool given by ANSYS, in this case Fluent.
On the bottom left of this interface, you can do any kind of post-process that you want. For example, this is the pressure distribution over the surface of the wing, but you can select many different things. For example, you can create a plane in a specific position if you want to study some kind of behavior. For example, this is the velocity magnitude around a specific portion of the wing. Or you can see streamlines, for example. In this case, you can see the wake of the wing, and modifying the shape of the wing itself can modify the efficiency starting the wake. Or last but not least, you can see streamlines animated. So in this case, a specific section of the wing and how the flow is moving around it.
Last but not least, we have tool number 4, which is an essential thing to learn. Guess what? Coding. Okay? I know that a lot of you studied the university thinking about, okay, I'm going to be a great engineer. I want to learn how to use CAD, do simulation, do the post-processing, but I don't want to be a developer. I don't want to be something that spends the days trying to code, create some kind of software. Don't worry about it. It's not like that. But this can help you speed up your work, automate a lot of different tasks, and with today's technology, using AI for example, you don't have to learn everything. You just need the thing that you really need for your specific case. So let me give you an example. We are gonna use something called Python.
For this example, I've created 4 different CADs and I want to see using Python which one has the highest efficiency, so L over D ratio. I gave to the AI some specific information and it's creating a little bit of coding for me to automate instead of doing it manually. And in a few seconds, you're going to see the volume meshes. Here we go. And on the top of each plot, you can see the efficiency of each wing. I'm sorry you cannot see the surface mesh, but if you want, you can do it. It's going to take you a few minutes. And in this case, instead of doing it manually, what I did was giving some clear instruction to the AI model that you want to use. It did a specific procedure to calculate for each Fluent simulation that I did, the efficiency, plot all together, and show me which wing has the highest efficiency.
So, for those of you that are still watching the video, I'm gonna give you a final thing that you can use if you don't want to spend a lot of money buying these kind of softwares, okay? Because let's face it, not everyone can afford thousands of dollars of licensing every year just to do our job. So there are free tools that we can use to repeat these tasks over and over, but without spending any money. Let me show you. So, if we talk about CAD design, we have something called FreeCAD.
This is the official website of FreeCAD, and as you can see, with this software you can create very complex geometries and 3D models, from mechanic to aerospace, architecture as well.
If we want to talk about computational fluid dynamics, like in this tutorial, we will need 2 different software, something to create the mesh and something to simulate. So, to create the mesh, we can use OpenFOAM. I'm not gonna go into OpenFOAM because it's gonna be a lecture of like 20 hours or more, but this is a free tool that you can use for meshing and also simulating.
Let's start from their official website. You have a lot of different documents, quick start guides, tutorials. You have to navigate a little bit the platform, but There are plenty of things that you can see, tutorials you can do. For example, depending on the sector that you're interested in, you can get a lot of different tutorials. Like in this case, you can see a specific example of how the air is moved by a fan inside of a room.
But if you don't want to use just OpenFOAM to do your CFD, you can also use another free tool called SUSquared.
This is their website, and this is a tool very useful for aerospace and automotive applications. If you go to the tutorial section, you can find tutorials about 3D wing like this one. Here we go, CP distribution. You have all the goals, the mesh. You can get all the input and output files as well.
And let's move to task number 3, which is validation. So if you want to do some post-processing and compare your results, analyze the data that you got from the simulation, you can use a free tool called ParaView. This is a free tool, very useful. You can do a lot of different stuff, basically everything that you can do with Fluent post-processing, you can do with ParaView as well.
So this is the official website of ParaView, but in this case, I want to show you the mesh of our tutorial. So this is mesh number 1. You can rotate and see the mesh from any angle, and if you want, you can compare different meshes. In fact, this is mesh number 1 compared to mesh number 3 of my CADs that I created before. And this is a useful tool that you can use for any kind of post-processing. For example, now I was looking at the differences between the topology of the two, but you can use it for anything.
So we don't have to buy anything because Python is free, and for task number 4, you just stick with the thing that I give you before. So let's resume everything. Being able to draw something with a CAD software, simulate CFD or FEM, whatever kind of simulation you're into, validate and post-process the results, and try to automate and speed up everything using a little coding, okay? So that's it for today. I'll see you in the next video.